All right, let's get right into it. Today, we're looking at a really clever framework designed to solve a huge problem in AI. How to keep these incredibly powerful systems from just collapsing. We've all seen this happen. An AI is performing brilliantly, and then, seemingly out of nowhere, it just becomes brittle. It gets repetitive or starts making basic mistakes. Well, it turns out it's not random at all. There's a hidden danger in how these systems work at a massive scale, a kind of invisible pressure that builds and builds until the whole thing just snaps. And that collapse often leads to something called a semantic black hole. Just picture the AI's huge creative potential shrinking down into this tiny, self-reinforcing loop. It's like an echo chamber. Sure, its answers become super predictable, but that also makes them dangerously fragile, totally unable to handle anything new or unexpected. To really get why this happens, we have to totally rethink what we're optimizing for. See, it's not enough to just reward the AI for spitting out a good answer. We have to start managing the health of the entire system and pay attention to all the hidden costs that are created along the way. So the old way of thinking was simple, right? Just maximize the immediate value. Did the AI's answer work? Yes? Great. But this new framework says, hang on a second. We need to maximize surplus. And what's surplus? It's the value that's left after you subtract all those hidden costs, things like system strain, how tired your users are getting, or the future rework that a messy output is going to cause down the line. This quote from the source material just nails it. An AI can give you a spectacular answer that looks great on the surface, but behind the scenes, that same answer could be burning through resources, creating a massive backlog for your human reviewers, and pushing the entire system one step closer to failure. It's quietly producing negative surplus. Okay, so what's the solution? Well, the idea here is to build a real-time control system. Honestly, the best way to think about it is like a dashboard for your car, with 3 critical gauges that are constantly monitoring the AI's health. And these 3 gauges are our early warning system. They're called SSI, CRP, and SSE. Let's really quickly break down what each one is telling us. So first up is SSI, the Saturation Stress Index. This one's all about capacity. It's watching for things like full compute queues or a pileup of jobs for human reviewers. Basically, it's the gauge that tells you when your system's resources are about to be totally maxed out. Then you've got CRP, the Collapse Readiness Proxy. This gauge measures how fragile the system is becoming. How shaky is it? By tracking things like how often outputs need to be fixed or redone, it warns you when the system is so brittle that even a tiny little shock could trigger a massive failure. And finally, there's SSE, or Semantic Spread Entropy. Now, this one is our direct alarm for that semantic black hole we mentioned earlier. It measures the diversity of the AI's outputs. If this score starts to drop, we know for a fact the AI is getting stuck in a creative rut. Now here's the really cool part. These gauges aren't just passive warning lights. They feed data directly into a central controller. It's like a smart thermostat for the AI. When it senses the system is under stress, it doesn't just ring a bell. It actively and gently adjusts the AI's behavior in real time. And the best part? No expensive retraining needed. And the whole controller is driven by this one simple-looking objective. J equals V minus lambda gamma. Don't worry, it's not as complex as it looks. This is the mathematical brain of the thermostat, and it's constantly balancing the push to create value against the risk of creating waste. So here's how it works. First, the controller figures out V, the potential value of an output, the good stuff. Then it subtracts gamma, which is all the predicted waste or dissipation, things like the AI drifting off topic or getting stuck chattering between different tools. And finally, lambda. Well, lambda is the magic dial. When those gauges detect stress, the system turns up lambda, which increases the penalty on creating waste. It just gently steers the AI back towards safer, more productive behavior. And maybe the most practical thing about all this isn't some massive fundamental overhaul of your AI model. The whole thing is designed to be a super lightweight middleware layer. It just sits right between the AI model and its final output, which makes it way easier to actually implement. And this chart really shows the immediate payoff. You can get some really big, high-impact wins with very little effort. For instance, the source material talks about pilot tests, where even simple versions of this controller/format errors in structured tasks by up to 50%. That's a huge deal.
They even lay out a clear 90-day plan to get this whole system up and running safely. You start in shadow mode, just collecting data without affecting users. Then you slowly roll out the automated nudges to a tiny percentage of traffic. And finally, you expand to full pilot programs where you can actually measure how many incidents you're preventing.
So what's the bottom line? This isn't just some cool technical theory. It creates real, tangible business value. We're talking about dramatically less costly rework, higher system throughput, fewer major incidents to deal with, and on top of all that, a clear, auditable trail for governance.
Ultimately, this whole framework really challenges us to shift our mindset. The goal can no longer be just about making AI more powerful. It absolutely has to be about making it stable, resilient, and trustworthy. And that forces us to ask a really important question. Are we building these systems for a short-term sprint, or are we building them for a sustainable, long-term marathon?